There are four primary components to a regular expression. They are character classes, quantifiers and alternation, groups, and anchors. While there are other components that can be incredibly useful, these are the ones you will predominantly use. Complex regular expressions are created by combining these components. To illustrate these different components, we can use this sample regular expression that matches a valid date using month, day, year notation. As we will see, this is a straightforward regular expression, but it isn't perfect. It will mark some dates as valid that aren't. The text contains both valid and invalid dates. Since we want to match all the lines that are valid dates, we need to make sure that we have enabled the flag for multi-line matches. Note that I have provided links for all of these regular expressions in the course documents for your convenience. Character classes specify the characters you want to match, or in some cases, not match. This example contains a number of different character classes. Each set of brackets defines a character class. For example, the first character class matches any single uppercase letter. On the left, you can see the different ways you can specify character classes. The first way to use a character class is to explicitly list the characters we want to match. The second approach uses the caret to indicate that we do not want to match the following characters. If the characters we want to match are grouped, such as all uppercase letters, we can specify the range instead of having to type out each character. This is what we did in our example. If we don't care about specific characters and just want to match a single character, we can use a single dot. The dot matches any letter, number, whitespace, etc., except for a new line character. The next six character classes are shortcuts for common classes you may use. You could specify them using the previous methods, but these shortcuts make it easier. The second character class in our example matches all lowercase letters. However, note that it has a set of curly braces immediately after it. The curly braces define how many characters we want to match. In this case, we want to match a minimum of 3 letters, with 2 of them being lowercase, and no maximum. Let's look at the quantifiers and alternation option on the left to see how we can do this. The plus symbol indicates that we want to match one or more of the previous tokens. In our example, we see plus signs after a /s, which denotes a whitespace. The /s is the token, and the plus means we want to match a pattern that has one or more whitespace characters. The asterisk or star symbol indicates we want to match zero or more of the previous token. This is similar to the plus symbol, but allows for no match at all. The quantifier, which is denoted by the curly braces, allows us to specify minimum and maximum quantities to match. The comma is used to separate the minimum and the maximum values. If we only use a single value and omit the comma, the regular expression will look for that number of tokens exactly. If we keep the comma, however, the single value can specify either the minimum, as in right here, or the maximum, depending on the position of the comma relative to the value. In our example, we have a minimum of 2 lowercase letters, but no maximum. Also for the year, we match 0 to 3 digits after the 1 or the 2. If the question mark is the only quantifier, it indicates that we want to match 0 or 1 of the previous tokens. This essentially marks the token as optional. In our example, the question mark is used in two places. The first is in the day. Since the character class that matches the digits 0 through 3 is optional, the regex will match days like the 24th that has a 2 in the tens place, or the 7th, which doesn't. There is also a question mark for the first digit of the year. This allows us to match the year 2021 and also the year 525. The last option is the vertical bar. This allows us to indicate we want to match one token or another. For example, if we wanted to match a time to go along with the date, we could use the bar to indicate either AM or PM. The last component we will look at are anchors. Anchors allow us to specify where a match starts and where a match ends. The two most used anchors are the caret and the $sign. The caret matches the beginning of the string or the beginning of a line if the multi-line option is enabled. The $sign matches the end of the string or the end of a line if the multi-line option is enabled. We use both in our example. This means that the entire line must match the date. If there is other text on the same line as a date, the date won't match. In this next example, we will create a regular expression that matches a number that is greater than or equal to the number 42. We have three different cases we need to consider. The first case is double digits that begin with a 4. Only those that end in 2 through 9 are valid. The second case is double digits that begin with the number 5 through 9. Any digit is valid for the second number. We can use the shorthand /d to represent any digit. The last case is numbers that have 3 or more digits, where the first digit is not a 0. This last qualifier is to ensure that we don't allow leading zeros. Thus, we have the character class for the numbers 1 through 9, and then allow 2 or more occurrences of any digit. For another example, let's consider a regular expression that matches a monetary value in US dollars that has either proper commas or no commas at all. First, we need to specify that the value can begin with a $sign. Since a $sign has a special meaning in a regular expression, we need to escape it with a slash. $sign is optional, so we add a question mark. Next, we allow any number of spaces between the $sign and the value, /s, and the asterisk. Then we search for a digit 1 through 9. This prevents matching a value with leading zeros. After that, we search for 0 to 2 digits of any value. If we allowed 3, then those 3, coupled with the previous digit, would be 4 numbers without a comma. If we don't want commas at all, we will account for that in the next part of the expression. The next section uses parentheses to group values into a single item. We first have an optional comma, and then exactly 3 digits. This entire group can be present 0 or more times, as indicated by the asterisk. The last group has a period and 2 digits, representing a value in cents. Since we want to match values with only whole dollar values, we want to make this entire group optional with a question mark. While this regular expression matches all the valid monetary values, it matches invalid ones. The problem with both invalid matches is with the commas. Since we made the commas optional, the expression matches values that use commas in some places and don't use commas in others. We need the value to be consistent and either use them everywhere or not at all. To do that, we can modify the expression to be the following. Here, we've expanded the term with the commas into two subgroups, one that uses commas and one that does not. The regular expression matches either case 0 or more times, but not both. To see how regular expressions can be used on the command line, we can use grep. Let's reuse the regular expressions we previously built to find numbers greater than or equal to the number 42. We have the file numbers.txt with the same test numbers we used on the regex website. To use regular expressions in grep, we need to use the -e option. I'm going to copy the regular expression we used a few minutes ago and put it in single quotes so Bash doesn't try and interpret them. Notice that we only got the number 42. We didn't get any of the other numbers that we got when we used the regexer website. That is because grep uses the POSIX standard for regular expressions. POSIX doesn't have the /d shortcut for digits. We have to explicitly use the character class like this. As an alternative, we could have used POSIX version of /d, two brackets, colon, digit, colon. Regular expressions are very powerful and provide you with the opportunity to accomplish some amazing tasks using just a few commands. In the next video, we will discuss how we can use regular expressions to replace values instead of just searching for them.